Earth impact 13,000 years ago, evidenced in multiple locations across 3 continents. The first thing that they found was evidence in North America. They found the same evidence across Northern Europe, and they found evidence in Africa and all over the world. A study examined 13,000-year-old nanodiamonds from multiple locations across 3 continents. Most of North America's megafauna, the mastodons, the short-faced bears, the giant ground sloths, the saber-toothed cats and American camels and horses, disappeared about 13,000 years ago, at the end of the Pleistocene period. The cause of this massive extinction has long been debated by scientists who, until recently, could only speculate as to why. The group of scientists, including UC Santa Barbara James Kennett, Professor Emeritus of Department of Health of Earth Science, posited that a comet collision with Earth, played a major role in the extinction, and their hypothesis suggests that the cosmic impact precipitated in younger dryas period of global cooling close to 12,800 years ago. This cosmic impact caused abrupt environmental stress and degradation that contributed to the extinction of most large animal species that inhabiting the Americas, and according to Kenneth, the catastrophic impact and the subsequent climate change also led to the disappearance of the prehistoric Clovis culture, known for its big game hunting, and to human population decline. In the new study published in Journal of Geology, Kenneth and an international group of scientists focused on the character and the distribution of nanodiamonds. It's a type of material produced during such an extraterrestrial collision. The researchers found an abundance of these tiny diamonds over 50 million square miles across North America, the Northern Hemisphere, at the Younger Dryas boundary, the YDB. It's a thin carbon-rich layer, often visible as a thin black line a few meters below the surface. Kenneth and investigators from 21 universities in 6 countries investigated nanodiamonds at 32 sites in 11 countries across North America, Europe, and the Middle East. And one of the videos I posted yesterday, we also found the same thing in South Africa. So this comet broke up into many pieces and kept on slamming the Earth in every position imaginable, every location imaginable. Now, 32 sites, 11 countries. 2 of the sites are just across the Santa Barbara channel from UCSB, and one at Arlington Canyon, Santa Rosa Island, the other at Daisy Cave on San Miguel Island. Quote, we conclusively have identified a thin layer over 3 continents, particularly in North America and Western Europe. And that contains a rich assemblage of nanodiamonds, the production of which can be explained only by cosmic impact, Kenneth said. We have also found YDB glassy and metallic materials formed at temperatures exceeding 2,200 degrees Celsius, which could not have resulted from wildfires, volcanism, or meteoric flux, but only from a cosmic impact. The team found that YDB layer also contained larger than normal amounts of cosmic impact spherules, high-temperature melt glass, grape-like soot clusters, charcoal, carbon spherules, osmium, platinum, and other materials. But in the paper, the researchers focused on multi-analytical approach exclusively on nanodiamonds, which were found in several forms, including cubic, the form of diamonds used in jewelry, and hexagonal crystals. Quote, different types of diamonds are found in the YDB assemblages because they are produced as a result of large variations in temperature, pressure, and oxygen levels associated with chaos of an impact, Kenneth said. These are exotic conditions that came together to produce the diamonds from terrestrial carbon. The diamonds did not arrive with the incoming meteorite or comet. Now, based on multiple analytic procedures, the researchers determined that the majority of the materials in the YDB samples are nanodiamonds and not some other kinds of materials. The analysis showed that the nanodiamonds consistently occurred in the YDB layer over broad areas. Quote, there is no known limit to the YDB strewn field, which currently covers more than 10% of our planet. indicating that the YDB event was a major cosmic impact, Kenneth said. The nanodiamond datum recognized in the study gives scientists a snapshot of a moment in time called an isochron. To date, scientists know of only 2 layers in which more than one identification of nanodiamond has been found. The YDB, that took place 12,800 years ago, and the well-known Cretaceous Tertiary boundary 65 million years ago, which is marked by the mass extinction of the dinosaurs, the ammonites, and many other groups. Quote, the evidence we present settles the debate about the existence of abundant YDB nanodiamonds, Kenneth said. Our hypothesis challenges some existing paradigms within several disciplines, including impact dynamics, archaeology, paleontology, and paleooceanographic paleoclimatology, all affected by this relatively recent cosmic impact, 12,800 years ago. And this was on phys.org by University of California, Santa Barbara. This is a map of various impact sites confirmed worldwide, and you can see, of course, even South Africa. And this has to do with an event that took place 12,800 years ago, slamming every single part of the Earth. So this was a cataclysmic event 12,800 years ago, a comet impact. A comet that split into pieces and slammed various locations on Earth. The Younger Dryas boundary locations at the end of the Pleistocene, about 12,800 years ago, quite recently, give or take a few centuries, a cosmic impact triggered an abrupt cooling episode that Earth scientists refer to as the Younger Dryas. The new research by University of California, Santa Barbara geologist Kenneth and the international group of investigators narrowed the date to a 100-year range sometime between 12,835 and 12,735 years ago. The team's findings appear in the Proceedings of National Academy of Sciences. The researchers used Bayesian statistical analysis of 354 dates taken from 30 sites on more than 4 continents. By using Bayesian analysis, the researchers were able to calculate more robust age models through multiple progressive statistical iterations that considered all related age data. This range overlaps with that of a platinum peak recorded in the Greenland ice sheet and of onset of the Younger Dryas climate episode in 6 independent key records, Kenneth explained. This suggests, he says, a causal connection between the impact event and the Younger Dryas cooling. In the paper, Kenneth and colleagues identified the thin layer called the Younger Dryas boundary, YDB, containing rich assemblage of high-temperature spherules, the melt glass and nanodiamonds, production of which can be explained only by cosmic impact. But in order for the major impact theory to be possible, the Younger Dryas boundary layer, YDB layer, would have to be the same age globally, which is what the latest paper reports. Quote, we tested this to determine if the dates for the layer in all the sites are in the same window, and statistically whether they come from the same event, Kenneth said. Our analysis shows within 95% probability that the dates are consistent with a single cosmic impact event. Altogether, the locations cover a huge range of distribution, reaching from northern Syria to California, from Venezuela to Canada. 2 California sites are on the Channel Islands off Santa Barbara. But Kenneth and his team did not rely solely on their own data, which mostly use radiocarbon dating to determine date ranges for each site. They also examined 6 instances of independently derived age data that used other dating methods, in most cases counting annual layers in ice and lake sediments. 2 core studies taken from Greenland ice sheet revealed an anomalous platinum layer, a marker for YDB. A study of 3 rings in Germany, tree rings, also showed evidence of YDB, as did freshwater and marine varves, the annual laminations that occurred in bodies of water. Even stalagmites in China displayed signs of abrupt climate change around the time of Younger Dryas, the cooling event. Quote, the important takeaway is that these proxy records suggest a causal connection between the Younger Dryas boundary cosmic impact event, the comet impact, and the Younger Dryas cooling event, Kenneth said. In other words, the impact event triggered this abrupt cooling. The chronology is very important because there's been a long history of trying to figure out what caused this anomalous and enigmatic cooling. We suggest, he says, that this paper goes a long way to answering the question and hope that this study will inspire others to use Bayesian statistical analysis and similar kinds of studies, which is a powerful tool. So the Younger Dryas boundary, the ice age that came at that time, which lasted about 1,000 years, was from a comet impact, a comet that broke up into various pieces and slammed the Earth in various locations. Within a 100, they limited to a 100-year time frame, about 2,800 years ago, which is quite recent. This is again from University of California, Santa Barbara on phys.org. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.